Yesterday we finished off with sum and difference of perfect cubes. And we said we were finished with that, but I want to look at this one here before we move on to factoring by grouping or greatest common factor twice. Now, the reason I want to look at this one here is because this is the first one. We had one previously that did have variables in both, but I do want to look at one where we only have the variable in the second spot. Now, the first thing we can do with this here is check to make sure there's not a greatest common factor between these two terms. And well, there's not. So our next step is to see if we can take the cubed root of 125 and the cubed root of x to the third. Now this helps us to verify that this is the difference of perfect cubes and to see what they are. Now the easiest one out of these two here is the cubed root of x to the third, because when the index and the exponent are the same, they simplify each other out. So the cubed root of x to the third is x. Now we can take the cubed root of 125, and the cubed root of 125 is 5. So now that we have this set up, we can do our parentheses. So our first set of parentheses will have 3 spots, and the second one will have 5. Once we get this set up, then we can do the signs. And it's going to be the same, opposite, always end on a positive note. So since we started out with a difference, the first one to be the same would be minus. The opposite of the minus will be plus. Always ended on a positive note. So we have minus, plus, plus. Now the next part is to plug in the first term. So we're looking at 5. Guys, let's focus up here. So in our first spot, we'll have 5. And the bigger one will have 5 squared, 5 to the first, and the last one would be 5 to the 0. But anything to the 0 power is 1. Multiplication of 1, we don't have to fill it in. Last thing we need to fill in is the second term. So in the first set of parentheses, we'll put x. In the bigger one, 5 squared, we could put next to it x to the 0, but x to the 0 is just going to be 1. Multiplication of 1 doesn't really change anything. In the middle one, we'll have x to the first, and the last one will have x squared. Now at this point here, we just need to simplify, so we'll have 5 minus x times 5 squared is 25, plus 5 times x is 5x, plus x squared. And this here would be our final answer. Now we can rewrite the quadratic if we wanted to. 5 minus x as x squared plus 5x plus 25. So that it is in standard form. We can flip the negative x and 5 to have negative x plus 5, but I don't like having that negative in front because it just doesn't look I don't know what it is, but I like the 5 minus x just set up over the negative x plus 5. Any one of these here is correct. Any questions on this here? Are you ready for the next one? Now the last set of factoring that we'll look at for this here is factoring by grouping. We call this grouping. And it's mainly because we're going to be grouping them together. I like to call it greatest common factor twice. Because what we'll do is with this here, we'll group it in even amounts. So 2 and 2, if it had 6, we can do 3 and 3 or 3 groups of 2. In any of these ways. And we're looking for a greatest common factor. So between 2p to the third and 5p squared, there's not a greatest common factor for a number because 2 and 5 don't have a greatest common factor. But if we look at p to the third and p squared, they do have a greatest common factor of p squared because we can take p squared out of both terms. And if we factor p squared out of 2p cubed, we're left with 2p. Plus, the 5 will stay, but the p squared will factor out completely. Because it's on one of the last pages. So it's at the towards the back. Any questions on this first part here? Now we can look at the next two terms, 6p plus 15. Now they're both positive, so we'll have plus. What is the greatest common factor between 6p and 15? 3. So we can factor a 3 out of both. And if we factor a 3 out of 6p, 6 divided by 3 is 2, and we still have p. 15 divided by 3 is going to be plus 5. Now what's nice or interesting with this, and this one here being able to factor by grouping, is when we factor the greatest common factor out of the first two, and out of the second two, we get a set of parentheses for both that is the exact same. And we can factor it out. So for this here, I'm going to factor 2p plus 5 out of both. And if I factor it out, or I divide it out of the first term, the only thing that's left is p squared. And if we factor it out of the second one, the only thing we're left with is plus 3. And that's it. That's also why I consider it greatest common factor twice, because we pull something out of both first and then do it again. Questions on any of this so far? We'll look at another one. You ready to look at the next one? 3n squared minus 4n squared, 3n cubed minus 4n squared plus 9n minus 12. Yes, sir. Unfortunately, we can't, because n cubed and n squared aren't the same thing. Now, it seems like we can, that they would give us the same value. Now, if we did 3n cubed minus 4n squared, because we could say that's what? Negative 1n. Subtracting those. Now, let's give n a value. We can say n is 2. So here we would have negative 2. Over here we can plug it in. 3 times 2 cubed minus 4 times 2 squared. 2 cubed, 2 times 2 is 4, times 2 is 8. 2 squared is 4. 3 times 8 is 24 minus 16, and 24 minus 16 is 8. Now, if they'd given us the same value, then yes, that would work. But as we see here, it doesn't. So the exponents do change it a little bit, because it's not the same value. It is very tempting to want to do, but unfortunately it doesn't work. Now, I will also say with this here on, say, the ACT or doing other methods where we're trying to figure out with division or multiplication, trying to remember, if I multiply like bases, do I add or multiply? Pick a number like we just did and try and see which one works, which one gives us the same value. Now, for factoring by grouping, I normally pick the first two and last two to do this with. We could rearrange it. I could use the 3n cubed and the 9n, or the 3n cubed and the 12, and group them that way, and it would still work. But this here is a little bit easier. For one, I don't have to rewrite the whole thing, and two, it's going to be easier to kind of, instead of mixing it up. Because if we look at 3n cubed and 4n squared, well, 3 and 4 don't have a greatest common factor. But n cubed and n squared do, and it is n squared, because n squared will go into both. If we factor n squared out of n cubed, I take 2 of them away. We're left with the 3 and 1n. minus. We'll still have the 4, but if I take n squared away from n squared, it simplifies it out completely, leaving us with 3n minus 4. Questions on this so far? Now, for us to be able to continue this on to our next step, the other set of parentheses over here has to be 3n minus 4. As if we're going to factor it out next, those two have to be the same, yes? So what do we need to factor out of 9n and 12 to get to 3n minus 4? 3. We need to factor out a positive 3, because 9n divided by 3 is 3n. Negative 12 divided by 3 is negative 4. So once we get one of them, we can use it to figure out what the other one has to be. Now at this point here, we can factor out the 3n minus 4 from both, leaving us with n squared plus 3. Any other questions on this here? Feel good with this here? Questions? Let's look at one last one. Let's look at this one here. And again, we can group it with the first two and last two. Now, the first thing we need to figure out, is there a greatest common factor between 224 and 56? 2 will work, but is it the biggest one? Clear all that out. Yep, clear. Now, the calculator, this is the graphing calculator, does have a function that's kind of nice. If you go to math, over to number, and all the way down here, greatest common denominator, greatest common factor, it will do it for us. But it only does 2 numbers at a time. So we can select this here and say 224, comma, 56, because those first 2 numbers were 224 and 56. What the calculator will do is figure out what is the greatest common factor, the biggest number that will go into both for us. And if we hit enter, it tells us that it's 56. Well, we know 56 will go into 56. We could check it. 224 divided by 56 is 4. So it will go into both. But unfortunately, we can't do more than 2. It would be nice if we could have said comma 21, but too many numbers. You can only do 2 at a time. But that is helpful for us because we can say, okay, 56 is the greatest common factor between 224 and 56. Is there anything else in common with these first 2? A. They both have an A. So we can factor it out. Now we've already figured out what 224 divided by 56 is. It is 4. And we'll still have the z, plus 56 divided by 56 is 1. A factors out. So all we're left with is c. Questions on this so far? So for the other one, negative 84yz minus 21yc, we need to factor something out of both of these here to get to 4z plus c. Because if we're going to be able to do the next step, we need those to be the same. Yeah. Now, this is kind of helpful because at this point here, without knowing this, we'd have to go through and figure out the greatest common factor between these two and work it all the way out. Now, this has yz, this has yc, so I know one of them has to be y. Both of these numbers are negative. These are both negative, and they need to both become, so I know I'm going to have to factor out a negative. This also has to go from 21yc to 1 YC. So the most likely number is, and if we check this here, 84 divided by 21, we expect this to be what? 4. Or Z. So once we get one of them, it kind of helps us figure out what the other one is. So normally when I'm picking which one of the two to do first, I pick whichever one is going to be easier to find the greatest common factor and then work from there. As the greatest common factor, so 84 divides by 84 evenly, yes? So what's 21 divided by 84? So it would work, it just means on the other one we would need 0.25C instead of 1C. And that would work just fine, it's just if we can avoid decimals, we try to. Now the last thing for this here is factoring 4Z plus C out of both. If we factor it out of the first term, we'll have 56A minus 21Y. And if it asks us to factor it by grouping, this here would be the final answer. Now, on some of the math tests you've taken before, or especially on the ACT, it doesn't sometimes say just factor it. It says factor completely. It wants you to factor it completely all the way down. And if it said to factor completely, technically, this here would be incorrect. And it's mainly the second set of parentheses that we would have an issue. Because if we look at 56 and 21, is there a number that will go into both? We can pull the calculator back up, say math over greatest common factor, 56 comma 21. 7. 7 will go into both of these. So technically it's not completely factored because we still have a common factor between those two numbers. So what that means for us is that this here, we can factor the 7 out. 56 divided by 7 is 8. So we have 8A minus 21 divided by 7 is 3Y. So to have that fully factored, we'd have to pull the 7 out. But we still have so this here is completely factored. The first one's just factored. But what that also means is that our starting numbers were all divisible by 7. So 224, well 56 we already saw it, 21 we know. It means 84 and 224 are also divisible by 7. So we could have pulled that out originally. Questions on this here? And that's it. That's all we're doing for today.